All right, so on to our second plant here. Let's just open up our image again. I'm actually going to skip plant B for now. It's a little bit more complicated. So we're going to go ahead and do plant C. And once we've done this, we can use some of the techniques from this to create plant B. It'll be a bit easier to sort of see how to follow along then. So this is actually a really fun setup. It's kind of based on a grass, and we are going to have a branch, and then we're going to have lots of little hairs sort of instanced along the edge of this. It's almost a bit like a feather, really. So let's go ahead and let's just create this now. So back in our object context, let's put down a new geo node. I'm going to call this plant B, plant C in fact. We've skipped plant B for now. Tap C and just color this teal. So all our plant models here are going to be green. Let's just dive inside. I'm going to make sure I've got hide other objects turned off. Now I think I'm going to model this one in the positive Y direction. It's going to be a bit easier to see this as we do this. And then at the end I'm going to rotate this with the transform just onto our positive Z axis, which will work better for our copy to points. So let's begin by putting down a point generate. This is just going to create a bunch of points at our origin, currently 5,000. We just want 3, and this is going to be the number of branches we have. So let's next put down a line sop. We're just going to create this to be 1 in our Z direction, like that. And let's just put down a copy to points and connect these two like so. So this is copying them on, but they're all lying on top of each other, so you can't see any difference. Let's just randomize some of our attributes here to kind of create a more convincing look. Let's first create a random normal. So put down an attribute randomize. Let's change our attribute name to be n. We're going to do a distribution of inside sphere. And this is just giving us random normals, which in turn is then aligning our lines along that. I'm going to turn on cone angle here, and we can actually use this to randomize around a sort of cone along a direction. I'm going to change our direction to be 1 on the Y axis, so X, Y, Z, this is Y, and now we can put in a random direction around our Y axis. Go for about 30 degrees, something like that. And we can vary this by coming to options and just adjusting our global seed. It can be quite hard to find a good value that you like, but feel free to play around with it. I've done this before, so I'm going to go for 1.21. And I think this is going to work quite nicely for me. Okay, so we are going to next put down an attribute randomize once more. See if I can spell this right. Attribute randomize. And then this time let's randomize our p scale. This is just a float value, so instead of a vector, we're going to make this dimension 1 for float. And let's just create a minimum value of about 0.7. And we can go as high as about 1.4. And again, we can come into our options and just randomize this as we see fit. I am going to go for 2.46 because I've done this before. And this was numbers that came out quite nice for me. Okay, so at the moment we have our line, which just has 2 points on it. I am going to resample this to give us more geometry, and then we're going to run a noise through this to kind of give us some more variety in the shape of our branch. So let's put down a resample here. I am going to change our maximum segments to be about 20, something like that. And I'm also going to enable our curve U attribute here. So now, to actually noisify these lines, we can use the same setup we used in our first plant. So I'm going to jump back here to plant A. I am going to grab this point VOP, which we should have named before. Let's just call this noise P. Hopefully you'll remember this was just taking our position. We were generating an anti-alias noise. We were multiplying that by our curve U, which allowed us just to have noise at the tip of our spline. And then we were adding this to our original position. So let's just grab this one, copy this, Control C, and just paste this into our new setup here. And we'll connect this after our copy to points. So for our values here, I'm just going to increase our frequency a little bit, maybe about 0.3, something like that. I'm going to increase our amplitude, maybe give it a bit more roughness this time, at 0.3. Maybe bring our amplitude down a little bit. Maybe just adjust our remapping here so it's affecting more towards the end of our curve, something like that. If I press play, you can see this is a little bit fast for my liking. I might just bring down the roughness a little bit more. I think I'm going to bring our offset animation down to divide it by 20. So it's now a very sort of subtle movement. Maybe increase the amplitude again a bit. This has kind of just got a bit more of like a moving in the air kind of feel. We're going to go with something like that. All right, so for now, let's just group these bits of geometries as branches so we can separate them later if we need to. I'm going to put down a group. It's going to be a point group. I'm just going to call this branch. So let's move on to our hairs next. What I'm going to do is I'm going to carve or delete away some of this branch and just create a section where I'm going to create a bunch of points and we're going to copy more lines onto that to be hairs. Let's put down a carve SOP here. And we're just going to trim away the bottom of our branch here, maybe go to about 0.55, 54, something like that. And I'm going to enable our second one. I'm just going to carve away the top, maybe just a little bit, maybe about 0.95. So we've got a bunch of points here already, but we're going to resample this to give us way more points. I'm going to put down a resample here. I'm going to go for a maximum segments of about 150. And I'm going to set treat polygons to be subdivision curves. Now this is a huge number of points, but this is going to be every sort of hair on our branch here. So we're going to be instancing lines onto all of these, which is going to give us our look. Let's just come up here and just grab our line and resample from before. I'm going to copy that down, holding Alt and dragging. Let's put down another copy to points. I'm actually also going to change our number of segments on this line. We don't need quite as many here, so I'm going to set this to about 7, I think. So let's connect this up. Click on that, and we're now copying a line onto every one of those points. Obviously we need to align this properly though, so let's come to our splines here, to our resampled points. We're going to create a normal attribute along the length of this curve. So we can use our good old friend orientation along curve, and just with its default settings, you can see we are now generating a normal that runs along the tangent of this spline. If we come and look at our copy to points, you can see this is now sort of creating this nice fan-like shape. Can put down a transform SOP just after our resample over here and just bring down our uniform scale a bit to make it a bit smaller. We could also do this with a p-scale attribute over here, but this is a little bit quicker, so I'm just going to use this for now. So let's vary our normal along our curve here, we're just going to put down another attribute, randomize. We're going to randomize our normal once again. I'm going to choose inside sphere, and again I'm going to check on our cone angle. Now this time, instead of setting a specific direction, I am going to enable the direction attribute and set it to be N. So now what we're doing is we are going to be randomizing our cone angle around our normal. So with nothing, it's going to be following along with our original normal. And as I bring this out, it's going to sort of spread these out and gives this nice sort of like feathery look to our normals. Somewhere around 40 degrees, I think, is going to be perfect. And then when we copy this onto our copy to points, we have all this. Might just bring down our transform scale here a little bit to about 0.25, 24, something like that. Okay, so that's it so far. Let's group these ones as well. So I'm going to put down another group SOP. This is another point group, and this time we're going to call this hairs. So we've got our hairs, we've got our branches. Let's select both of those. So shift select both. Then I'm going to hold Alt and just drag out from here to put down a merge. I also want to add a bit of noise to our hairs as well, so they're not just perfectly straight. So we can just take our noise P VOP from up here, just drag out a copy and just put it under our copy to points as well. So this time I'm going to maybe increase our frequency a little bit more. Let's go to about 3.5 perhaps. I'm going to bring our amplitude way down to about 0.1-ish. Press play. I'm actually going to speed up our animation a little bit of these because they're smaller. I'm going to do time divided by 5 just so they're blowing a little bit more in the breeze. I think something like that is quite nice. Gives it a little bit sort of undulation. So if we combine these now, you can see we've got a bit of a problem here where our hairs aren't actually sticking to our branch anymore. So the problem with this is we are using our curve U attribute to mask off our noise. We've created our curve U attribute on our line here, but the problem is we also have, as well as our curve attribute here, we've got a curve U attribute coming in on our points from our original branch. So it's actually using the curve U from our branch to mask this, and that's not what we want. We want to use the curve U here, which is going to run along the length of our hair. So the reason for that is essentially copy to points will copy attributes across onto the resulting geometry. So this is now copying our previous value from our branch. The easy way to fix this is just to delete our curve U attribute from our points before we use copy to points. So let's put down an attribute delete. Wire this in just before our copy to points and just delete our curve U. And now when we come down here, you can see these sit nicely on our branches. We've got this nice sort of movement like this. Okay, so let's next put down a sweep to generate some geometry from these hairs. I'm just going to drop down a sweep SOP. I'm going to wire this up to the first input, and I'm going to change our surface shape to be round tube. Now this is massive. We could change our radius, but the nice thing about sweep is it can also use a p-scale attribute if it has one on the points to set our radius as well. And this will be multiplied by that radius up there. So what we're going to do is we are going to generate a p-scale based on our curve U attribute of our curves here, and then we're going to use that to drive our radius. So let's put down a point wrangle. Let's call this set radius, and we can say float attribute p scale equals, Now remember, up here we have our curve U attribute, which will run along the start to the end of all our hairs, on both our hairs and our branches. So if we were to say float attribute curve U multiplied by, let's create a channel slider, CHF for channel float, and let's just call it radius. We're going to create our radius slider here. We can increase this now. So this is going to multiply our curve U by this value and set that to be our P scale. So the result of that is we are now able to adjust the sort of width of our radius on our sweep by this value here. Now I actually want this in the other direction, and it would be nice to have a bit more control over this as well. So instead of just using curve U, let's actually remap this by putting ch ramp, which is a channel ramp. We want to give it a name, so we'll call this remap underscore curve. We're going to put a comma and then float at curve U. We can now create this attribute here, and we can now remap our curve U based on this spline. So I'm going to flip this across like this. I'm going to maybe bring up our scale at the end, something like that. And I'm going to bring down our radius to be about 0.0, let's go 0.05. So now we've got sort of like a thicker bottom and a thinner top. So I also want to make the hairs to be much thinner than the branches. Now, because we have set these up to have both point groups for branch and hairs, we can actually copy this and just do a separate version of this that will just affect our hairs. So let's take our point wrangle here, just drag out a copy with Alt, drag. We're going to come up to the top here, and under our group, let's just set this to be hairs now. I'm actually going to leave this the same, but I'm just going to change our radius to be a little bit smaller. Let's go 0.02. And this is now only affecting the points that are in that hairs group. So this is basically making the hairs smaller while we're keeping the length of our branch the same. At the moment, we've got quite a lot of points, about 30,000 points. And I think we could actually reduce the number of rotational segments of our tube on the hairs, because they're going to be so small, we're not going to really even see them so much. So we could do this by adjusting our columns, and the best way to do this, I think, is just we're going to split this out and sweep these separately. So let's put down a split SOP here, and we can just tell this to split based on our groups. So I'm going to split branch to the left, and this is going to have our default 8 columns, so there's going to be 8 segments around our tube here. Let's Alt drag out a copy of this and connect this to our second output. This is going to be everything else that isn't our branch, so essentially it's going to be our hairs group. See, there's no points in the hairs group now. Sorry, no points in the branch group, and all our points are in the hairs group now. So for this, let's just bring this down to say about 5. So we're now reducing our rotational segments here. Set this to 5. I think that's about right. Let's recombine these just by merging these together. And we're now down to about 18,000 points. So we've cut a lot of the complexity of our geometry down. So these are looking a little bit faceted. If I just hit Shift W, you can see we've got some edges there. I'm just going to smooth this out by putting down a normal SOP here. Connect this one up. I'm just going to increase our cusp angle to make it smoother. As I bring this up, you can see it becomes more rounded. That's going to work just fine. Okay, so let's just have a look at what else we could do. Of course, you could go up here and we could say add in more points if we wanted to. We could increase the number to create more of these. I'm going to keep this at 3. We could as well change our cone angle of our N attribute at the top, which would allow our branches are sort of spread apart. I'm going to leave this about sort of 30, maybe 25. Might come and adjust this later. We could even adjust our carve here so we can make our hairs grow further towards the end or further towards the start. It's quite a fun setup overall. You could set up like a digital asset, or you could link these parameters so that you could turn this into something a bit more robust to make sort of like a plant generator. But I think for now we're just going to leave it around about this. Press play. This is what we have so far, just in terms of like ambient motion. Okay, so for the last step, let's just put down a transform sop. Press our handle tool. I'm just going to control and drag on this to rotate this down by 45-degree increments. I'm just going to line this up along our z-axis. In fact, because this is pointing a little bit below, I'm going to drag this up a little bit more just so that it's mostly facing along z like this. So it's not quite 90 degrees, about -76. And this now lines up mostly to face down this z-axis. In fact, I've actually done it in the wrong direction, as you can see. The positive z-axis is this way, so let's just hold control and just shift this 180 degrees so it's now facing down our positive z-axis correctly. And as I said before, I want to keep these plants roughly around sort of scale of 1 in their length, so let's just bring the uniform scale down a little bit, maybe around here. Something like that should do it. We might come and change this later, but I think that will do. So let's put down a null. Let's call this plant _c _out. And the next lesson we'll animate this on and set this up for its unfolding.